multiplication and division, the way it works is the base has to be the same. That's all you need. The exponent can be anything. So as long as the base is the same, if you're multiplying or dividing, let's call this division or multiplication, as long as the base is the same, the exponents can be anything. Okay? So let's call anything, this is a pink box, and that's a blue box. Okay? They don't have to be identical, unlike adding and subtracting. So the way it works is, if you had a squared times a cubed, the rule for multiplying and dividing exponents is, if you're multiplying them, you add the exponents. If you're dividing them, you subtract the exponents. So this is multiplication. The bases are identical, so you're okay there. That means the exponents can add. So 2 plus 3. So this becomes a2 plus 3, which is 5. So this just becomes a to the power of 5. And that's your answer. Right? So when it comes to multiplication and division, the bases have to be the same, the exponents can be anything. Let's do a few, right? So if you're multiplying two things that the base is the same, the exponent's different, well, the exponents could be the same or different, you just add the exponents. If you're dividing two things that the base is the same, you subtract the exponents. So let's do an example. Okay? So right now we got 120 a to the negative 2 b cubed divided by 40 a to the negative 5 b to the 5. Now what you do with the exponents, their bases are the same. Numbers, the coefficients in front. I think the numbers in front are just called coefficients. The numbers in front, they just deal together exactly the way they did in the real number set, right? So when we're talking about the first way, it's just adding or subtracting, multiplying, dividing numbers. So 120 divided by 40 is going to be 30. A to the negative 2 divided by a to the negative 5. What you do with division, you subtract the exponent. So it becomes negative 2 minus negative 5. So this becomes a negative 2 minus negative 5. And you do the same thing with the b, because the bases are the same. So it becomes 3 minus 5. So b, 3 minus 5. So we talked about this before, and negative becomes a positive, so this becomes plus. So this becomes 30 a to the power of negative 2 plus 5 is 3. B to the power of 3 minus 5 is negative 2. Right? And we talked about what negative powers mean when we were laying out all the transition or moving on from the rational number set to the exponents, and we said negative numbers, all it does is just kicks it down, right? If it's on the top, it goes to the bottom, bottom goes to the top. So the way this works is, now this negative 2 only applies to the b, it doesn't apply to the a or the 30, because these guys are in brackets to the negative, right? So the way it works is, go down here, no, okay, there. Here, yes. So this becomes 30 a cubed, that stays on top, over b squared. Are we on? And that's our answer, okay? So that whole thing just reduces down to 30 a cubed b squared. If you have something like this, a to the power of a half times a to the power of 5 over 3, what you got to do, you got to add the exponents. So this becomes a to the power of a half plus 5 over 3. And the way you add these is, well, you go a, you got to find a common denominator. Common denominator between 2 and 3 is 6. You multiply this by 3, so you multiply that by 3, so it becomes 3 plus. You multiply that by 2, 3 by 2 gives us 6, 2, so it becomes 10. So this thing multiplied together is going to be a to the power of 13 over 6. All you do is you add the exponents. And it doesn't make a difference how many different symbols, variables you have multiplying together or dividing together. So for example, you have repeat, hopefully. So we have 2 to the power of 5, a squared, b to the negative 2, times 2 to the negative 3, a to the negative 5, b to the 5. And the way it works is, all the bases, they're the same. Even if you had, let's say you had a w. Okay. We don't have a w here, but that's okay. Because all you do, you can put w to the power of 0, but that's going a little too far instead. So all you do is you deal with the exponents, okay? So 2 to the power of 5 times 3 to the power of negative 3. All you do is just add the exponents. 5 plus negative 3 is going to be 2. So it's 2 squared. A squared times a to the negative 5. 5 plus negative 5 is going to be a to the negative 3. Negative 2 plus 5 is going to be 3, right? So it's going to be b to the power of 3. And your w is just your w, it's just solar. Now what's the final answer for this? Well, 2 squared is just going to be 4. 2 times 2, you're quoting itself. So it's going to be 4. A to the negative 3, we talked about this in the layout of the exponents when we're transferring over the information from the rational number set to the exponents, or laying down the properties of exponents. And negative power means you flip it, right? And the only thing that flips here is the a, because that's the only one to the negative power. Now if it was negative 3 to this whole thing to the negative power, the whole thing would have flipped. But the negative 3 right now only applies to the a. So this becomes divided by a to the power of 3. You got b cubed and w on top. Okay. And that's your final answer. So when you're multiplying, dividing bases with exponents that are the same, you just add or subtract the exponents depending if you're multiplying or dividing. Now let's do a little bit more complicated exponent to a fraction. Let's assume you had so let's see what multiplier times e to the power of negative 3 over 2, 5 over 7. Okay? Complicated enough? Sure. The way this works is, this is just multiplication. So anything that has the same base, you can combine their exponents. So this is multiplication, so it becomes a squared times a negative 3 over 2, so you're just adding those guys. And for the b, you're just adding those guys because it's still multiplication, right? So this would be a 2 plus negative 3 over 2, b a half plus 5 over 7. Now, the way you do this, you got to do your common denominator. The common denominator, that's just over 1. Common denominator here is 2. So this would be a to the power of, well, the common denominator is 2. You multiply the 1 by 2, so that becomes 4. And that stayed the same, so that stays the same, minus 3. The b becomes, the common denominator between 2 and 7 is 14. Multiply this by 7, so that becomes 7. Plus, multiply that by 2, so that becomes 10. So we got this, this. 4 minus 3 is 1, so this becomes a to the power of a half. Right? And for the b, it's 7 plus 10 is 17, so it's b to the power of 17 over 14. Still on? 17. Cool. Does that make sense? Hopefully.